Hello everybody, today I'm going to talk to you about three new JavaScript operators that you can use today. So these three operators are being inspired by Ruby and they are a stage 4 proposal, which means it's finished and is going to be added as a standard for the next JavaScript version, but all major browsers already implement this feature. So you can use these three operators today everywhere. So the first operator I'm going to talk to you about is the Nullish assignment operator. So imagine you have this cat class and you want to assign its name. You can assign it a constructor or you can assign in a setup. So imagine this setup has an expensive logic and you should really call it only when necessary. And another case that is also fairly common will be that the setup has some side effects, like changing the state of your application in the sense of changing the DOM operation or sending an HTTP request. So you really don't want to call it unless it's actually a change. So in today's state of JavaScript, you can do a simple if statement checking if the name is a false value. If the name is a false value, then you can assign a name and you can check the set is called right here. The name is the one that we assign. Now, when we do this if statement, we are checking for false values, like false 0, an empty string, another number, a null, or an undefined. But if we actually desire just to set it when it's null or undefined, then this syntax won't work. Let me exemplify a little bit more. For example, if we assign the cat a name as an empty strings, and that's his name, and we check for false values, we can see the name was assigned where it should have been. So in the case of having a cat with a name of 0 characters might be a little bit weird, but if you are checking, for example, the lives of the cat and you're trying to it's an integer value and 0 is a completely valid value, it's not null, then the distinction between falsy and nullish becomes really important. So we could try to rewrite this using the nullish coalescing operators, of course. So what we can do is, alright, I assign a cat with already a name, and I check, heck, I'll assign the cat's name. So it can be if this is how I will read a knowledge coalescing operator. Like, assign the name they already have unless the name is nullish. But if the name is nullish, assign Luna. Alright, so we check it and we see that it has its name. It never assigned Luna because it already had its previous name, which was Peppa. Alright, so one little caveat is that the setup it's being called even though there was not a change in the name. So if we want to avoid calling the setup like here, then we could try to make it a little bit more like lazy like checking first, making an expression to check first, and then if that expression passes, then execute another expression. So if we do that, imagine here. All right, so this name is called Pepper, right? And we say, hey, if the name is Nullish, I'm going to execute this expression. And this expression says assign it a name. When we do that, we can check and see, hey, the name is still Pepper because Pepper is not Nullish. Now, if we assign the name a Nullish value and we repeat this operation, now we can check that the cat's name. This setter is this one. This is the assertion again, and here is a setter. So here was the previous setter, and now it doesn't exist, which is nice. And now the setter is called here, and that means the setter was only called when it was strictly necessary. I mean, when the actual value of the name was Nullish, and not every time. So that's great, but this expression is quite convoluted to write, right? So what the proposement is saying is, hey, we have many short sequence syntax for other kind of assignments, like for example, the add assignment, the multiply, the subtract, which says, hey, if I'm going to do a operation with my own value, then I can short that syntax and say add this value to my own value. But these are in arithmetic in nature, yeah, right? They are summing, multiplying, subtracting. These are arithmetical. So the proposal is saying, hey, we should have some logical short circuits, right? Like if the value is Nullish, assign. So there's where the logical Nullish assignment comes into place. Now check it. If we have a cat, a newborn cat, and we use the logical Nullish assignment operator, we can check, hey, it assigns the name of Artemis to our cat because the name was Nullish. And if we try to assign a new value, it will still have the previous value because Artemis is not Nullish. You can tell it, hey, here is the getter of the Nullish operation being triggered. It says, hey, yeah, it's undefined. So the set is called. Here is the assertion. And here's the second Nullish being called, and there is no setter, and here's the assertion again. All right, now this is a terse syntax because the setters is not called needlessly, and there is no repetition of code, so it's a very terse and it's very succinct. It makes our code cleaner just by the nature of the expressiveness of these logical assignments. Right, so that's done for JavaScript. As I told you before, the compatibility of this feature, you can use it today in Chrome, in Edge, in Firefox, and in Safari, and in Node.js from the 15th version, which was released in October of 2020. You're gonna use in Internet Explorer or Opera in the desktop, and in mobile you cannot use it on Opera for Android and in Samsung Internet. I will still say that it's available in the very much growth of the internet. Before continue, I will remember you that it's a big deal for me if you comment, like, subscribe to this video. If you would like to read this article, actually, it's below in the description. The second operator is the logical and assignment, and is, for example, if you already say assign if Nullish, we should need something like assign if truth, right? Like some sort of update operator. Like if the previous operator say, all right, if there is no value, now assign this value. But it will be nice to say if there is a value, I want to update it, and is the logical and assign operator. Now, how does it work? I can show you in a second. Here. If we have a value 0 and we try to add it again, 0, perfect, 0. If we have a value of 1 and we want to set it at 1, if we have a value of 0, we want to set it at 1, so it's 0, it's not going to get assigned. This is also a short secret, so you should see it just as the previous expanded expression, but shorted. So it's like if this expression and this other expression, right? So 0 is falsy, and if we're trying to send something to it, it's going to say, no, it's falsy, I'm not going to do anything. Now, why it's truthy? So you say, all right, if I assign something to it, it's gonna get assigned, so it's 1 and 0. Now, this short circuit evaluation, I'm going to go a little bit deeper because I already showed you before what's the meaning of these operators. So now we can jump a little bit deeper on what the short circuit evaluation really means. So from the MDM documentation, we can check. All right. The logical AND operation is evaluated left to right. If it tests for possible short circuit evaluation, use the following rule. All right. Some false expression and an expression is short circuit evaluated to the false expression. So short circuit means that the expression part above is not evaluated. Maybe I read that wrong. Short circuit means that if this is falsy, this part of the expression is not evaluated and is not called, like we already know when we try to do some Boolean logic in today's JavaScript. So what this operator is saying, I am equivalent to this expression. So not evaluating the left side if the right side is already truthy. And it's not equivalent to saying, hey, make a logical assignment of the logical result of x and y, because making this expression means that the x setter it's always called, and it will mean short syntax but not short circuit. I mean laziness, not evaluating the right side of the expression. The compatibility is exactly the same as the previous operators. So now, the logical or assignment, which is the missing piece here. Now, what if we actually meant to evaluate for a faulty logical assignment? Just as the first example, we're if. Now, if we already have these two nice operators that are very terse, avoid repetition of code, are very lazy, so we should have shorter syntax for the actual if statement. And here you have it. All right. If we have a object with duration and a title. Now, if we do the logical or assignment and we assign 10 to the duration, we can see that the duration is not altered because 50 is not a false value. But if we assign title is empty when the title is an empty string, which is falsy but not nullish, we can check and see that the title is actually changed and the title setter is called the implicit setter. Of course, we didn't make a setter here. Another useful example that is talked in the proposal discussion is the case for HTML. For example, in here we say, hey, get the lyrics element, right? And assign in the text content no lyrics. So why, if we put this line of code in our setter, it's very dangerous that it's being executed all the time, because manipulating the DOM can change the focus of our application. So if we are constantly assigning things, even if they haven't changed, we might be possibly changing the focus of our application, which we will be prevented if we make logic inside the setter. But thanks to these new assignment operators, there is a short circuit in place that allows text content to only be called when we want it, that is when it's falsy, or when it is nullish, or when we actually already have a value. So we can do everything we can think in the sense of basic Boolean logic. So the short circuit mechanism works like this. Now, X or Y returns X when X is truthy and Y is not evaluated. Now here Y seems like a variable, but it can be an expression. And if X is truthy, then Y expression is not going to be evaluated. But it returns Y if the X expression is not truthy. So then again, we can see the actual short circuit, if expanded to today's JavaScript, will be this syntax. That is, if X is falsy, then assign Y to X, and is not equivalent to assign X if X is truthy, otherwise Y, which means calling X setter all the time. And the compatibility is the same as previous. So here I have two questions for you just to finish this article. And is, do you find yourself using these operators in the future? And can you remember a time when you say, hey, I need this, and I know I'm not being, how could you say it, performant or logically valid because I'm making unnecessary assignments on my code. And thanks to these operators, I can be much more terse, expressing what I actually want to express on my assignments. And the second question, which actually interests me a lot, if you're a JavaScript like very fan of fun and you work with JavaScript all the time, you are probably very familiarized with the future proposals in the JavaScript TC39, which is the board that decides what comes next for the MacScript standard. Do you have any proposals that you are really eager to see finalized? For example, for me, that will be the pipe operator, which is a big deal in functional language, and it's a big deal for readability because it really allows you to see your code top to bottom, and it really makes your code really beautiful to observe and easier to understand. So what are yours? I would really be glad to know. Please comment in this video what you think about all of these three operators, and see you on the next one.